Right, so welcome back to Dr. Carr Society Mission. So we are now on chemistry for lower primary. Okay, like we said, we look at the same topics that we have in chemistry for those in SHS and then the A level and those in the university as well, maybe up to the first year university, chemistry up to that level. We look at all the topics, okay, in chemistry, and then bring them down to the level of ages 6 to 8 or 9, right? That's lower primary. So all that we're going to do will be the same topics that will be learned at the upper class or in the SHS A level first few years of your tertiary education. Those topics that we learned, all the topics, we are not leaving any out, are the topics that we are going to teach at this level. Of course, we are going to teach them at the level that they can understand, or at the level that they can have tools to play with. So the strategies that we are adopting here is one, we are using what we call the play. Two, and then two, we are using what we call the sketching. Okay, so for each of the topics, okay, when you choose a topic, we have the play tools or the toys for that particular topic. And you can request, you can call on us and you can send the play tools to you or the toys to you. Then you can allow the preschool child or kid to play with them. Okay, we'll show you how they can play with that. Okay, then as they keep on playing with it, it builds up in their mind, and then by the time they get to upper primary, GHS, SHS, it makes our teaching very simple. And this is the secret about us. We make sure all the topics that they are supposed to learn in the upper primary are taught at their level in the lower primary. And of course, at the GSS level, SHS level, they are all part of the topics. So all the topics that you meet at the SS or SHS level is what we are going to talk about now. We have play tools for each of the topics, okay? So you can make an order, you can place an order, and then we can deliver them to you for a certain period. When you are done, it's returned. If you want to have it purchased, there's an arrangement for that one. Then we come to the sketching. Sketching is usually for the lower primary. The play tool for the preschool, this is the play, okay? So the preschool play, we have a special toys that we have already mentioned that they can use. Now the play comes in the form of, let's say if it is motion, this is under chemistry, but if it were motion, we have the tools that can be used for the various types of motion. The same way we have tools for the various topics in chemistry, and that's what we are talking about. So these two are for lower primary, and then the first one is for only the preschool kids or children, and then that is more about play, okay, how to play with the toys. Okay, so we have toys, they are locally manufactured toys, okay? Manufactured. We have some foreign as well. Okay, so the two are combined, and then they are used for the play. So let's use the same method that we have used for chemistry for mathematics. We are going to extend the same method to teaching chemistry now. Right. So let's start with the first chapter. So every chapter at the SHS level or the A level up to the first year in university, we're going to go through or for ages 6 to 8 and 9. But of course, we are bringing them to their level. And then to make it more interesting, it's going to take the form of drama and play. And then we have sketching. Sketching, this one will mean drawing. That's, let me put it here. Okay, so the kids are taught, or they are shown pictures that they try to sketch. And we have already told you, we have done a lot of research, we know why we let them do that. And we have the skill, we have a way of doing it, teaching you the parents or the guardian, okay, or the studies teacher, or whatever you call them, how to let the kids, demonstrate the skill by drawing and then sketching for the various topics that we're going to go through. Right? So this, our school, we are going by a different, not only different, but also research based and then also research supported way of teaching this. Of course, this is being done in addition to the traditional teaching that is going on in our schools, okay? So it's more or less like a supplementary kind of teaching aid. Right, so let's proceed. So for chemistry, we will not be able to do chemistry without knowing the elements. The elements, that's the element that we have in our part of the world, okay, or let's say in the world, right? So let's say before we go on, the illustration is this. You have to, so we are playing the tools, the play tools, then we are using the sketching. Okay, so this is going to be more of sketching. The play tools, you can request for them, and then you'll be taught how to use them. Right, so it's also taught, how to use them is also part of this teaching that we're going. So let's assume this is a big thing. Our kids are familiar with this box. Let's say something like this. It's a cube, okay. This cube will be made up of very, very small particles coming together. Very small particles coming together. Okay, it's just like we have the sugar cube, okay? Something that they can relate to. So let's say this is the sugar cube, okay? So that these small particles are there. So this is one of the small particles. We can also break this one into pieces. Then we can have something like this. Okay? So breaking it into pieces like that. You can break this one also into pieces. Then you can get something like that. You can break it and then eventually we get it. Alright? Until we get to one level that we call the smallest level. The smallest level particle. That we cannot divide. I'll put here at our level, I'll put here divide. Okay, so those that we can't divide any further. The smallest one that we can divide any further, okay? Is what we are saying. So that one is so small you can't even see it. Okay, something like that, very small. We will call that one atom. Okay, so as we keep on dividing, so if the cake, we can have a cube, break it down into pieces, further, pick one particular pick until it's the smallest one that we can divide. We are calling it atom. Okay, or we call it atom. So this is the smallest one. So we can't divide it here. We call that atom. Now, if we were to make it big, right? If we were to make it big, then it would be something like this. So it will have something in its center, okay? And then it will have something moving around it. Usually those in the first half, there are 2. The others can be 8, or they can go up to 8. So let's say in this case they are having 1, 2, 3, 4, 5, 6. There are 6, right? But they can go up to 8. So let me put something like this here. So this is our atom that we are talking about. Right. So as we keep on dividing, the smallest one that we can divide is atom. And this whole thing here, you see, we can call it matter. Call it matter. So divide until we get to this level. Right? Smallest one that we can divide. So you can let them play with the sugar and then go on like that. And then you come to the sketching. So those in the lower primary, you can let them sketch. Draw, sketch. So keep on dividing. And then they come to this. You can let them sketch something like that. So this one, this is called the nucleus. It has protons. It contains protons and neutrons. Depending on the level, you may skip this or you may mention it. Okay? And these are the electrons. We call them electrons. Let's say one is electron. Okay? And then this is the path. This is the path, or what you call the shell. Right. So this is what we are having. So this can be the first shell, the first path, which we call K. This will be the second. So we can go on to the third and fourth and so on. L. So the third will be called KLM. Okay, so we go in that. This shell that we have, this shell that we have. Sometimes the shell too, we can, this is up to this level, that is okay. Somebody said, Oh, can't we also divide? Can't we get a very small, maybe the particles, the electrons, we can get additional power for them? Maybe we can get additional power for them. Maybe. Somebody will say, okay, that may be power, we can have an S. Maybe we can have another one where we have S, P. Okay? And maybe we have another one, and so on. So they can come in these forms. Have an S, SP, maybe the next one will have what? SP, D. The next one will have what? SP, D, F. So, right. Okay, so we can keep on having, but this is not what we are talking about. There is something. Right. So ours is this. So we have the nucleus, protons, and neutrons. We have the power, which is the cell. We have the electron. Okay. Right. And these ones, some will call it the orbital. So we are like that. We are going. Keep on going. Since even this, now it is even for adults, not for ourselves. Can we also divide this one? Can we divide this one? Maybe we can divide it too. Divide it into something else. Maybe when we grow up, we will know that they divided. Right? So that is how the picture is. They can also be divided. And the pathways they are going to be divided, you can look at what they also come with. Okay? So energy. So here, all that we are seeing is what? We are seeing energy, strength. There's strength in this thing. Okay? There's strength, energy. And then our material is there. Okay? Energy and material. Our material coming together. Okay? Right. Energy and our material coming together. And this thing is going to give it what? It's going to make it very heavy, so it may have what you call mass. Let's put mass here. Okay. Especially for this one. For this material, we can have what you call mass. Then when you are on Earth, if something is pulling you, the Earth is pulling us, so our mass will be called weight. Because something is pulling us towards the center of the Earth, our mass will be called weight. Okay? Right. So there's some it is going like that. So the sketching can go on. You can let them be sketching. And don't mind the words, okay? Let's play with the sketch, okay? Drawings. So you can let them sketch this one, sketch that one, go, and then they sketch something like that. Naming, forget it. And let them keep on sketching as they go on. And of course, you can request for the play tools, okay? The play tools, we have something like that that they can play with. Okay, when it's time for these topics, you can look at that. Okay, so this is what you have. Wow. So you also go up and then maybe you say those that we divided electrons into, we divided protons into, divided neutrons into, okay? Those ones too, what will be their name? Further divided, keep on going. Okay, and so you see that here you always have material and then you have energy. The energy is holding them. This thing is something that can cause a very big explosion. And that happened in Japan, okay, during the Second World War. So Japan during the Second World War, okay, there was a big explosion. Boom. Okay, and that was what we call the atomic bomb. Right. So big explosion in Japan. It's the ancient time or the olden days, okay, when our forefathers, our great grandfathers were fighting. There was a big explosion and they used this atom in making that bomb. Okay? Right. So this is what we have. So that is it. The elements we are talking about. This element is the same as the atoms, okay? So when you have atoms, the same atoms, let's say A, same atoms, we call them elements. When they are together, we call it elements. Okay? Same atoms. If it is A, B, C, then it's not element. It will be called molecule. And they are together, and then it will be called molecule. So the sketching can go on. A together, A, B together is molecule. A together is element. A, B together. Or maybe plus C will be called molecule. Okay. Right. So the sketching can go on. Sketching. Right. So at this point, this is what they have for the first topic. We are talking about elements. Now, it is also good to have the 20 elements. So you must learn the periodic table. That is the essence of their level, especially the periodic table, and how to spell them. How to spell the various elements. So let's name the first element. Hydrogen. What's helium? Okay. Lithium. Radium. All right, so this is the periodic table. So this is the periodic. Okay. Now we have what we call the modern periodic table now. The modern periodic table. Okay. Right. So that one, the numbering is changed, and it is based on the atomic number. This is based on the atomic number. Unlike the traditional one, the old one that had, which was based on atomic mass by Mendeleev, okay, was based on atomic mass. But the modern periodic table, which is the current one we are using, is based on atomic number, because atomic number relates to the features of the elements better than atomic mass. Okay, right. So this is the first 20 elements. So we let them look at them. Always the first 20. So some will say, I would say helium, like beating, boys, come near our flowers, knee, nine, maybe, always see me, people send, calling, album, Kwame Charles. That is my own way. Alright, so you can have your nice one. And of course, from the after 20, we have the first 10. We have the 10 elements coming in between here. Okay, that's what we have the 10. We call them the transition elements. They are there, a lot of them. Okay, so we have SC, I say science teachers visit children, men, female, Koniku, zinc. Right, that is my way. Alright, so you can also divide it very nicely. So at least I have my first 20, I have the 10 transition elements there, and I'm gone. Right? So this is the periodic table. Okay, you can let them look at it. So when you have, once you have this periodic table, you can tell the charges. Okay, the first one, those here, they are young +1, those here are +2, those here we were +3, and then if it were to say this one is neutral, it's in between, so you can go anyway. Okay, this would expect to be -3. Okay, but let's see, that can also go anyway. Then this is -2. Okay, that can also sometimes go anyway. And this is -1, and of course here is neutral, it's 0. Okay, it's neutral, no charge. So those which are no charge, they are not very they can't react. Okay, not that they can't react, they are very stable. They will not react at all. They are not charged, so they can't attract and cause problems or cause reaction. So these ones are not very reactive. Okay, especially neon, argon, and then we have others here, which will krypton and so on. So these ones, you see, they are not reacting at all. So we say they are inert gases. Okay. Or noble gases, okay? Noble gases. And these are elements. So the elements, there are some which are metals. Then you come towards the transition metals. So you are changing, they are metals, they are changing into transition metals. Okay? Then we are going towards semiconductors. Okay, we have the semiconductors coming in. Okay, and then we go to the non-metals. Okay, so something like that. At this point, just something like this is enough. Okay, so just be looking at note the naming and all that. That is very important. Okay. So I think this is a good way to go. You can always try to sketch this for our lower. For the preschool, this is what you do. We have the clay tools, okay? So they can come in cardboards, different colors, okay? Cardboard. So you can ask them to arrange them arrange them into shapes. Okay, you arrange it for them. Maybe you do the first two, you let them also try. Okay, just arranging these ones into various colors. Okay, the colors suiting the color of the letters and so on. You can have that one. That play can be there, or you can show the picture. Okay, and as they keep looking at them, and to give us a very good. Now what you do is you can talk. You know, children like to listen to stories. So you can talk about why the name is NA. Something small about the name. Maybe related to Latin name. So why this is potassium, but it's K. So these are the symbols, okay? The symbols that we are using, okay? The chemical symbols, okay? Helium is He, okay? Lithium Li. So that most of them, the first two letters may be for the first two words, but not all the time, okay? Or it will just be the first letter, okay? So those ones are there. So here we have the names and then the symbols are there. And then of course, like we said, the charges. This plus 1, this plus 2. Okay, so once you know the charges, so those here are plus and those here are negative. But here, 0, they are neutral. They are going to react that much. So you can play around. Okay, once they want to know the charge of oxygen, then they may ask, they may be able to answer right. So that is how we should be dealing with how to play with these ones. Okay. Of course, the spelling must also come in. So you must go around, and when you are done with this, then go to the next level. You can even go to the end of the periodic table, getting all the elements. Right. Okay, good. Now let's look at the next one, atoms, okay? So let's say we have this is our hydrogen, okay? Hydrogen atom. It is neutral, okay? It has electron, 2. In this will have the protons. So this is an electron, 1 electron. Okay. Now it is here. It is 0. Okay. 0. The charge is not charged. So it's an atom. You can take electron away. If you take the electron away, you can't do this. Okay. The electron was negative, so this one is negative, and this here is positive. So if you take electron away, what we have only positive. Electron is away. It's going. So here is what? Positive. Say this one, ion. Call that ion. Okay, so it's now a positive ion. Positive ion. Okay. Don't mind the words, okay? Let's write it there, put it there. Positive ion. So this is gone. This is our hydrogen ion. Right. Okay. Now we can have hydrogen here. 1, and then another hydrogen also comes. Another hydrogen. So here we have 2 hydrogens. So hydrogen and hydrogen. They are sharing. They are each pulling. This is positive. Here is positive. Here is negative. Here is negative. Here is positive. So they are sharing. Sharing. This is called. You can put the 2 together and say they are H2. And this is what you call a molecule. This is a molecule. Okay. 2 elements. Okay. 2 elements together. Okay. Two atoms together. So when you have to say these 2 atoms coming together, you say it's a molecule. Okay? So when you have any 2 atoms coming together, or 2 or more, so 2 or more, or sometimes it's even the whole, sometimes even the one component alone. Okay? Then we are looking at it. So it's a molecule. So there is a molecule. Okay? So there is what. So we have A and A linked to A. Can be A linked to B. They are all molecules. Okay? Some of these molecules will be charged. Then we have this one positive, this one negative. See, some may be charged. Okay, the whole thing may have positive charge, or the whole thing may have negative charge. Okay? So, right, they are all there. Now, when they are different, then we are looking at people. Okay, so compound is an example of this. It's an example of molecule. So all these either AA together or AB, so all together, they all be molecules. Okay. But when they are different, so they are compound. Okay. When they are the same, they're simple molecule. And these ones can stand. They can stand on their own. They can live alone. Okay, live alone. Live alone. Okay, live alone. Okay, and say they are molecules. Now here we form the compound. The charge one and the charge one will come together. Okay, and the compound coming together. So it's that the compound, different ones. Okay, coming together. Okay, here same thing. Different ones compound. Same thing. The two together molecules. The different one called compound. So that is it. Right. Okay. So what we are saying is, if it is let's say A, this will be element. And it is also a molecule. Because it's standing alone, it can exist by itself and can be put on. Then we have A to B. There's a compound. So that's a compound. Okay, the two are all molecules. Okay, right. Then you can have the charge. If they are charged, if they are positive, positive is cation. If it's negative, it's anion. Okay, so the words you can learn them for our spelling. Our spelling. Learn them for our spelling. Right. So that is that. Now we just look at it. Okay. So the drawing is what matters, how we draw them. Okay. So I have this one. It's an atom. This is charge, this is negative. This we can have together. That's A and A. A and B. And we add one. These are molecules. So there is an element, the same thing. This is a compound. So this is cation. This anion. This is an atom. Okay. So the picture is going to make you remember things. It's going to make it clear. Okay. So this charge is not charge. That's an ion. Ions. Okay. So here we have lost electrons. Either they have lost, or let's say, or they have gained electron. Okay. If you lose an electron, you become positive. If you gain an electron, you become negative. So the sketching, you can let them sketch. Okay. Sketching is what is important here. The other names you can remember them, and the names they can learn them from our spelling B. Right. So that is it. So this is the picture, just the pictures. The sketching is what we are talking about. Let them sketch. They sketch and they can name them. When they sketch and they say this one is an element, this is compound. So this one, they are living freely. They can exist on their own and live freely. Okay? They are molecules. Okay? So that is that. So the play goes on. Look at this one. So we are looking at amount of substance. Okay, so we have this container here. We have water in it. Then this is our salt. This is our salt. Okay. 1, 2. Now let's put them in. Put them in. We stir. Then we stir them. Stir. Then we have clear salt solution. Salt solution. So here we have how many? We put 2, so we have 2 particles in here. The cup is giving us measurement. It says 10 cube. So 2 particles in 10. Do more. Now you can change and put 5 cube or 5 inches, then it will become 5 particles. So you keep on changing, and then you can taste it. This is just for salt. If it is something else, don't need to taste it. Okay? So we only play with the salt, and so the salt solution. You can also use sugar. Sugar, the cubes. You can use the cubes to do it. How many cubes did you put in? First, let them measure something like you can measure. that has reading on it. Look at the 10, then you pour 2 or 3, then make it right. Okay? Now later you can give numbers, or you can give mass. You can give number, give mass, and say it is in, instead of centimeter cube, you can change to decimeter cube, and so we have followed it there. So of course the metric table, people will start learning them. So where we have what? 1 millimeters, we have 1 centimeters, we have meters. Okay, so we have also decimeters. So kilometers, we are not going to talk about it when it comes to our these 3, these 4 are what we usually use. So this is what we have. Let's not go to it. Just play with salt solution, sugar, okay? And then we see which one is having more. We can let them tell which one has more sugar in it. So then start, okay? They are also learning how to measure. Oh, so the clay tools are there. First we put them to. Okay? So the amount of substance only move. So particles. More particles. Okay? So the weight of something, how heavy. How heavy something is, the mass. Okay? And then once you have multiplied by the earth pulling it, we call it weight. Right? We'll come to the difference later as we go. So we come to formula. Come to the chemical formula. So you can let them choose after the 20 elements. Knowing the 20 elements. Okay? And then they start with hydrogen. Then we have chlorine. Okay? And write them together. Okay? Have lithium. We have what? Fluoride. Put them together. So here this is always positive. This is positive. This is negative. So we can let them try. Just pick any of the 20, put them together. Always the positive here. And then let them put them together. So if I have magnesium here, and then I have oxygen here, put them together. Don't make it complex, something like that. Okay, something that, so just putting them together. Okay, so you can let them sketch it. Here they are together. So just something small, you don't go into it, just a plate, you write two and then let them write together. That's it. Right. Now you can also demonstrate interatomic and then intermolecular kind of bonds. Okay? So interatomic and intermolecular bonds, okay? So you have two, see you draw one with charge positive, one with charge negative. They are attracting like magnets, okay? Here they are sharing. They are not charged, they are sharing. Okay? Sharing. Okay? And here the atoms are here. And then these ones are moving. Okay? So this is covalent. This is ionic. This is covalent. And this is metallic. That is what is happening. You can let them sketch. So just sketch, let them draw and sketch. Okay. And here we have one, this one is standing alone, this is standing alone, this one is alone. They are in the crystals. Let's say sodium chloride, salt. This one salt particle, this one salt particle, this. Yeah, body. So here they are not sharing, they are separate, but they are attracting each other. So you can let them demonstrate. You can have salt for this one, and use salt. This you can just draw. This is a metal, so you can put metal piece in there. sketch. So it's not a name. This is what I'm putting just to show you the teacher, okay? But this is what they are going to be drawing. You can let them draw so many things. Just sketching around. These are elements, okay? And of course the plane, we have the power plane, this thing, we can use magnetic dimension. We can use magnetic dimensions. Okay?